Hello everyone, welcome back to the channel. So in the previous session we have looked at vibration isolation, whereby we know that in order to reduce the effect of vibration, we can use vibration isolator. And the vibration isolator consists of resilient members where we have stiffness and also damper. We also have looked at the transmissibility ratio, which is either force transmitted over excitation force or X over Y. And we also have to look at this plot, whereby in order to get the lowest transmissibility ratio, the frequency ratio must be higher than square root of 2, which is this region. And if you want to get higher transmissibility ratio, or TR is over 1, the frequency ratio needs to be in this region, which is less than square root of 2. So now let's look on some problems. For example, so for this example, the seat of a helicopter with the pilot weighs 1000 Newton, which means the pilot plus the helicopter plus the seat is weighing around 1000 Newton and is found to have a static deflection of 10 millimeter under self-weight. So static deflection, this is the delta, and this is the weight, which is W. The vibration of the rotor is transmitted to the base of the seat as harmonic motion with frequency 4 Hz. So what is this for? This 4 Hz is actually the forcing frequency and amplitude of 0.2 mm. So what is this amplitude mm? Okay, so this is generally more towards the displacement transmissibility, whereby if you read here, the vibration of the rotor is transmitted to the base with frequency of 4 Hz and amplitude of 0.2 mm. So if you can recall from the previous session, this is actually the Y, because this is the amplitude transmitted to the structure. So the question asks us, what is the level of vibration felt by the pilot? The amplitude of acceleration. So the first question asks us for acceleration, which is A. And the second question asks us, how can the seat be redesigned to reduce the effect of vibration to 10 millimeter per second? So if let's say the A is 10 millimeter per second squared, okay, so how do we redesign it? Okay, so this is actually example 1 in your lecture notes. So we have W equals to 1000 Newton. Static deflection is 10 millimeter. The forcing frequency, which is omega, is 4 Hz. So I recommend you to convert it into radian per second, which would be 25.13 radian per second. And the Y, because it's the amplitude transmitted to the structure, so the Y is 0.2 millimeter. So it asks us for the first question, amplitude of acceleration. Alright, so generally, you know that x equals to x, and x dot is actually omega x, and x double dot is omega squared x. So for the amplitude of the acceleration, we need to find the x double dot, which is omega squared x. So how do we find this x? We already have the omega value, which is this one. Next, we need to find the x. So from the transmissibility ratio, you know that TR is equals to x over y, which is, if you refer back to the previous slide, these are some of the other ways that you can do other than the example shown in the lecture notes. I use this equation, c squared over k minus m omega squared plus omega c squared. You can use both, you can use any of those equations listed here. So either you use this one or you use this one. Okay, so in your example it shows that you use this one, but I'm going to use this one because I don't want to find the value of zeta and everything, so I prefer to use this one. Okay, so we know that we need to use this equation, okay, because we need to find the x. So let's look at the value that we have. We know that we have y, we don't have the k yet, we have omega, and then c we don't have. But if you look at the example, it doesn't mention it, or it doesn't provide you with the value of c. Therefore, we assume that there is no damper, therefore c is equal to 0. So when c is equal to 0, this equation can be reduced to this. Therefore, TR is actually x over y, which is equals to square root k squared over k minus m omega squared squared. So we have this one, we have omega, we don't have m, but we can find the m, and we don't have k. So in order to find the k, you know that omega n is equals to square root k over m. So what is the value of m? We know that W is equals to mg. So 1000 Newton is equals to m multiplied by 9.81. Therefore, the m is equals to 101.94 kilogram. So how do we define the k? Okay. So in order to find the k, we know that static deflection is actually Fo over k. So Fo, which is the excitation force, is coming from this weight. So it is actually, so the Fo is 1000 Newton. And the delta static is 10 millimeter. Therefore, K is Fo over delta static, which is 1000 Newton divided by 10 millimeters equals to 100,000 Newton per meter. So now we already have the value of K, we have the value of M, yeah? So we can straight away get the transmissibility ratio in order for us to find this acceleration. So again, since there is no damper, because we don't have any value of C, there's no C or no zeta, which is the damping ratio. Therefore, x is equals to 1 from the equation of transmissibility ratio, k squared over k minus m omega squared. So y is 0.2 mm. So 0.2. Remember to use SI units. So k is 100,000. Don't forget squared here over 100,000 minus 101.94, which is the mass, multiplied by the omega, which we have defined here, 25.13. Squared. So we will get the x value as 5.614 to the power of minus 4 meter, which is equivalent to 0.561 millimeter. Therefore, the question asks us to find the x double dot, the acceleration, which is omega squared x. So omega is 25.13 squared multiplied by 5.614 minus 4 equivalent to 0.354 meter per second squared, or 354.3 millimeter per second squared. So we have solved the first question. So moving on, the second question asks us, how can we redesign so that the A, which is the acceleration, I put it as A prime, to be 10 millimeter per second squared. So for vibration isolator, we know that it relates with omega n. And we know that omega n is equals to k over m. So it's either we change the m or we change the k value. Now it is undesirable to change the m. So generally what engineers do is that they generally play around with the value of k. So basically we need to find the value of k for the vibration isolator so that the acceleration would be 10 millimeter over second squared. So to solve this, we know that A is equals to omega squared x, and because of we have a new A, therefore we will have a new value of x. So x is A over omega squared, which is 10 millimeter squared, over omega squared is 25.13 squared. Therefore, the new x would be 1.583 times 10 to the power of minus 5 meter. So generally, because we need because we want the value of acceleration to be 10 millimeter per second squared. Therefore, we will have a new value of x, the amplitude, which is 1.583. Alright, so what we need, again, what we want is we need to redesign. So we play around with the value of k. We need to find the k in order to get this a. So we know that TR, transmissibility ratio, is x over y. And x over y, because we don't have any damper, therefore 1 over r squared minus 1. Okay, so now I am using this equation, okay, because we don't have any value of zeta, therefore this is equal to 0, this is equal to 0 because there is no damping. So we left with square root 1 over 1 minus r squared to the power of 2. So forget this one. So from here we know that x equals to so from here we know that x equals to y square root of 1 minus r squared minus 1 to the power of 2. So if I square root this, okay, I will get y over r squared minus 1. So r squared minus 1 is y over x. R squared minus 1 is 0.2 times so R2 minus 1 is 12.63. R squared is 13.63 and R is 3.692. So why do we find this R? Because we know that R is the ratio between the forcing frequency and the natural frequency. So by using this R, we can get the omega n, by it is square root k over m. Therefore, we can identify the k. So from here, omega n is omega over r, which is the omega is 25.13 radian per second. So 25.13 over 3.692. So we get the new natural frequency, which is 6.807 radian per second. So from here we know that omega n is equal to square root k over m. In order to find the k, so omega n squared multiplied by m is equals to 6.807 squared multiplied by the mass, which is 101.94. We get a value of 4.723 kilonewton per meter. So generally, in order to redesign the seat of the helicopter so that we can get the value of acceleration to be 10 millimeter per second squared, therefore we need to use the spring coefficient of 4.723 kilonewton per meter. So it is straight away, it's not that hard, it's just that you need to understand on the techniques on which one to use. Alright, let's look on another example. Example 2. Okay, an exhaust fan rotating at 1000 rotation per minute is to be supported by 4 springs, each having a stiffness of K. So we have an exhaust fan which rotates at 1000 rotation per minute, and it has supported by 4 springs, where each spring is equivalent to K. So if only 10% of the unbalanced force of the fan is to be transmitted to the base, what should the value of K? So generally, if only 10% of the force is transmitted to the base, what is the value of K? Assume that the mass of the exhaust fan to be 40 kg. So generally, it asks us what is the value of K if only 10% of the force is transmitted to the base. Alright, this is one way related to the transmissibility ratio. So generally, the 10% is actually your transmissibility ratio. Alright, sometimes the question play around with the wording. So let's see, instead of using this sentence, okay, it writes like, if the isolator provide 90% vibration isolation to the base. Okay, so if let's say the isolator, okay, managed to prevent 90% of vibration to the base, therefore the transmissibility ratio is not 90%. Okay, the transmissibility ratio would be 100% minus 90%. Therefore, the transmissibility ratio would be 10%. Alright, so you need to read carefully when you get the question. Okay, sometimes it plays around, it gives straight away the value of transmissibility ratio, or sometimes if it says that 90% vibration isolation to the base, that means what you need to do in order to find the TR. TR is actually 100% minus 90%, which is 10%. Alright, so to solve this, okay, we have the value of N, which is 1000 RPM. Transmissibility ratio is 10%, and the mass is 40 kilogram. So if I draw it, okay, we have a pump with a mass of M, and it rotates RPM, and is supported by 4K here, K to the base. So what is the value of K? So if you look at here, there is no information about theta or no information of C. Therefore, we can assume that there is no damper. So again, it relates with the transmissibility ratio. Because there is no damper, therefore the equation will become 1 minus r squared to the power of 2. So we already have the transmissibility ratio, which is dr, and what we need to find is actually the r in order for us to get the omega n. So from r we can get the omega n, and from omega n we can get the k. So 10% is actually 0.1 square root of 1 minus r squared to the power of 2. So if I remove this square root, so I need to power on the left, so 0.01 is equals to 1 over 1 minus r squared, 1 minus r squared. Okay, because why we have 2 here? Because it is 1 minus r squared to the power of 2. So 0.01 is 1 over 1 minus 2r squared plus r to the power of 4. So 1 minus 2r squared plus r to the power of 4 is equals to 100. So r to the power of 4 minus 2r squared minus 99 equals to 0. So using your calculator, okay, you can get the roots, which is r squared is equals to 11, or r squared is equals to minus 9. We know that the ratio could not be negative value, so r is square root of 11, which is 3.317. So from the r value, you know that r is omega over omega n. So the r value that we get is 3.317 is equals to 104.72 over omega n. So how do I get this 104.72, which is this omega value? So if you learn mechanics of machine, we know that omega is 2 pi n over 60. So 2 pi, the n, which is the rotation per minute, is 1000 divided by 60. This results to 104.72. So the omega n is 31.571 radian per second. So remember that we need to find the value of k. Okay, so omega n is square root of k over m, and k is omega n squared n, which is 31.571 to the power of 2 multiplied by 40. So we get the value of k is 39.868 of Newton per meter. Alright, we need to note that this k value is actually the total k, whereby kt is actually 4k, because we remember that the question have 4k here, okay, 4 spring here, so that the value that we get for this one is actually the total k, which is 39.868. So in order for us to find the k, So K is actually 39.868 times divide by 4 because we have 4 springs there. Therefore, we will get the value of 9,967 Newton per meter. Right? So again, what I would stress is that because basically this K is actually the 4 supports that we have for the motor. Okay, here we have 4K. So in order to identify a single K, so you need to divide by 4, so you will get this answer. So again, this chapter is quite straightforward. It wasn't that hard. Okay, so I hope you can do or you can answer any question related to vibration isolator. So that's all for now. Thank you very much and see you again. Thanks.